Playing guitar is simple. You just hit the strings and sound comes out.
Or is it?
Fundamentally, the sound of a guitar comes down to waves, and specifically two different types, progressive and stationary. When you move one end of the string, a wave is formed, and the wave moves down the string and then essentially falls off the end. This type of wave is known as a progressive wave, as it moves down the string and is the most commonly known wave type.
However, if you fix both ends in place, the wave is reflected off the end and interferes with itself, forming a stationary wave.
The wavelength of the primary wave on the string is 2 times the length. There are more waves on the string though, as one wavelength isn't enough for a full sounding instrument. These different waves then create different frequencies that combine together to create tone.
This equation is called the wave equation, and in general shows that the velocity of a wave equals the frequency of the wave times by its wavelength. This equation is for the velocity of a wave on a string, where velocity equals the square root of tension over the Greek letter mu, where mu equals the mass of the string divided by its length. We want to combine and rearrange these equations so we have an equation for frequency. First replace mu with mass m over length l, then rearrange to get wave velocity equals the square root of tension times by the length of the string divided by the string's mass. Then, using the wave equation, we can replace the v with frequency times wavelength, and finally divide by wavelength to give our complete equation of frequency equals the square root of tension times length over mass, and then all of that over the wavelength.
It is important that we have this equation for frequency, as frequency is the pitch that we hear, so changing the frequency makes up the different notes on a guitar. As the equation shows, when you decrease the wavelength, as done by fretting a string, this increases the frequency. So as you fret further down the string, the frequency increases, making a higher pitched note. You can also see that changing string will change the pitch, as each string has a different mass, so going from the A string to the G string will increase the pitch because the mass is decreased. It is also important to tune your guitar, as this is what affects the tension, which is another key factor in the frequency.
Therefore, if your tension is wrong, you will be out of tune, and your notes won't reach the desired frequency. Now that we have vibrating strings producing standing waves, we need to consider how this sound is amplified to a volume that we can hear it. On an acoustic guitar, this is done through the hollow body vibrating at the frequency of the strings, in combination with its natural acoustic characteristics. The hole in the body allows air to escape, making the guitar louder. An electric guitar is similar but uses magnetic pickups to convert the string vibration into electricity, which can then be played out an amplifier.